Hi, today I want to show you how to create and run containers using Go. You can do it with the Docker SDK or with containerd. I'll show you the differences. Here you see in this diagram on a high level, we can use Go containerd client library to connect to a containerd Unix socket, which will bring us to the container daemon, containerd. And when we start a container and we want to run a container, it will execute runc. With Docker, we have the same. You have the Go Docker client SDK, which can send commands to the Docker Unix socket. You end up in a Docker daemon and it will also use runc. Now, the big difference is that the Docker daemon can actually communicate with runc and can also do your networking. Containerd is not really responsible for networking right now. So containerd has been built just as a lifecycle management tool for containers. So it will use a certain runtime, for example, runc or other runtimes. But those runtimes, they are not really responsible to create the networking. You have different tools for that. Those different tools don't really have an API exposed. So it's quite difficult to build a Go program that would easily create the networking. You have nerdctl, so nerdctl comes from containerd.sock, which is currently CLI only. If they would expose an API, you would have the same capabilities as with Docker, but currently I checked on their GitHub page, they don't really have an API. So you can actually alias nerdctl into Docker, so the commands are exactly the same as in Docker. You just do nerdctl run Docker container or network create and so on. Nerdctl will communicate with containerd for you, and it will also do the networking. So it has some kind of hooks to then do the IP tables, the IP addressing, interfaces, and so on. And also, optional, it has a rootless mode. So there is a rootless daemon for containerd that nerdctl also supports. So you can run all these things without root, unlike the Docker daemon. And then you can have some kind of namespace network that can then do the networking for you. So that's all interesting. But there are still some advantages. Using the Docker SDK. Although today I will show you how to use the containerd SDK because the Docker tooling is actually not free. It's free for small companies, but then you get into a paid tier. So it might be useful to have a look at how to do it in containerd. Also, Kubernetes is using containerd, so adoption in the future of containerd will probably be higher than Docker, because a lot of the projects are switching the Docker runtime into the containerd runtime. But then they also need to kind of bridge this gap of networking, and eventually they probably will have an API for networking so that you can write your own clients that will do end container runtime, container lifecycle management, but also networking. I'll show you how the networking is done now. For example, if you use something like Lima, which is a Docker desktop alternative, which I used to run containerd on my macOS. So let's have a look at the code. So I just have a package main. I use containerd version 2, which is right now in RC. So it's a release candidate, will be stable pretty soon. So I'm using this client. I created the start container function. Let me start with what I'm passing to the start container function. I need a context, the socket, which is a string, and the target platform, because target platform is going to be different. I'm here on my macOS system, and the target platform is a Linux system, because containerd actually doesn't work on macOS. It can run, but there is no runtime for it yet, because even the Docker desktop just runs a Linux VM first, and then It runs all the Docker containers within the Linux VM. There is no native support currently for macOS. Which I mean the Darwin architecture. So to support macOS, you kind of just run a Linux VM on macOS. So we first get a home directory containerd socket. So I'll have to make sure that I have a containerd socket on my Mac available. So I will use this Lima VM for that. Target platform is run C v2, which I have to pass. And then I just do start container with those parameters. And then I'm going to initialize all what is necessary to create containers. I'll make sure that this code is also on my GitHub repository. I have a Go demo GitHub repo where I will put this one. I'll make sure that the link is also supplied next to the video. So here we have the client. Containerd is this containerd package, the client containerd package. I do new using containerd socket, and I also say I need my default runtime needs to be this IO containerd run C v2. If there's an error, I will capture the error. If we continue, then I will defer the client close. So at the end, we will close this connection. Within containerd, there are namespaces. So you can isolate the different containers depending on the namespace. I'm using the default namespace because that's the same namespace as nerdctl is using. So then I don't have to pass the namespace parameter with nerdctl, so it just makes it easier. I have this no-check platform that I pass as a parameter when I pull. So because I'm on different architecture, I might have to pass some extra arguments. Maybe it's necessary, maybe it's not necessary. I had some issues that I needed to resolve to do this. So I added a few parameters that might not even be necessary. If you're building this on a Linux system and running this on a Linux system, then it's not going to be necessary, because basically I'm just saying that I want to pull a container of the Linux platform and not of the Darwin platform, because I'm going to be on a Linux platform. I'm going to have a Linux VM. This containerd is going to run on a Linux VM. So I do a pull. I have to pass this container context. So this container context is just of type context, but that's just the context of this namespace in containerd. So I'm going to pull this. Always going to pass this container context. I'm going to say I want to pull this nginx image. I want to unpack the image for the Linux ARM64 platform, and I don't want you to check the platform, so that if there's any incompatibilities because I'm on Darwin, I will still want you to continue. So then I want to create a new specification to run my own container. That specification needs to be based on this image, this nginx image. So I'm going to do generate spec with platform, and I'm doing this with platform because you also have generate spec, because I'm on Darwin platform. So there's a lot of issues actually if you run this on a macOS instead of a Linux instance, and the containerd is running on a different platform, because it's not really made for this. It's all possible, but ideally you just run the code on a Linux platform. Then you don't have these issues on the same platform, because these libraries are used by the clients, like the Docker client, the nerd client. I'm not sure if the Docker client is using it. Not these libraries. Is Docker using containerd as well? Yeah, so Docker is also using containerd. In 2022, it was an experimental feature, maybe just in there now. So this code that I showed you is definitely also in Docker itself, because it adopted also containerd for container lifecycle management. So generate spec with platform. So I do this because it's a Darwin architecture, but I want to make sure that we are creating a spec for the Linux platform. Containers nginx. and then we pass the container image. So this is just a lower level function that we use instead of just with spec, because here with spec we could also pass our with image config directly. But what we want is we want to make sure that this is for the Linux platform. Otherwise I got an error actually. So I try to do it directly with spec and then passing this image to say I want to run a new container image based on this image, but it gave me an error, something like platform Linux is missing because I'm doing this on a Darwin platform. So that's why we are doing this line here to generate a spec specifically for Linux. Then we can pass a container spec. We also put the C group path to nothing because the target system containerd that we are running it on is using systemd C groups. So this needed to be set. Otherwise you also get an error. We do client new container context, the name of the container. This is going to be the ID. Could be also as well a unique ID. That's what the Docker client and the nerd.sock uses. They use a unique ID. With a new snapshot, this is our root file system, and with the specification. We defer the delete of the container. So once we exit here, then it will delete the container. Then we're going to create a new task. Here we can pass our std standard in, standard out if you want to. We are not doing this because we are not on the same system. So I also tried this, but because the socket is mounted and we are not on the same system, I got an error that it couldn't find some files that it needed to read. So there is some communication that communication that is not going to happen because we are on a different system. Defer the task delete, and then we can say what is the process ID of this task. We're going to put it in this process ID. Then we can start the task. And then we can wait until the task exits. So we don't really need this code if you just want to exit after the task has been created. But if you want to wait until something happens, until someone stops it, then we can see task exited with a certain status. So how do we run this now? We need something called Lima. Brew install Lima, I think I did, which is basically just Docker desktop, but based on containerd and nerd.sock. So what I did to get this containerd.sock, when you start Lima for the first time, you can edit the configuration. So I added a few lines. Lima ctl edit to edit the configuration. So here at the bottom, I added provision, mode user. If this file exists, delete it. Otherwise, link this file from proc. There's here a containerd.sock that runs as my user. So it's not as root. That's why it's such a long path. It actually is not in just run containerd.sock, but it is in the root of the user that is running containerd with this rootless, with this containerd rootless. Then mount this under containerd.sock, and then we do a port forward of our containerd.sock into the home directory of my Mac containerd.sock. So this was just necessary to expose this containerd.sock on my whole system. So Lima ctl start will then start my Linux VM using QEMU, run Lima to open the shell. So now I'm in my VM. Let's have a look where you have the containerd.sock. We have containerd.sock. And then if I look in my home directory here, we have also the containerd.sock. And this is on the symlink. So we should be able to communicate from our Golang program to run to run this nginx container. And maybe just to get an idea, nerdctl, I will show you the differences with nerdctl. So if we also run something like an nginx container, we'll call it to nginx. Here we do a port forwarding. That should work. Nerdctl run. Oh, need to clean up my old one first. So used nerdctl stop nginx 1 and 2 and remove this one. And then let's start this one and let's run this Golang program. Container has process ID 2525. And here we have 2525 nginx nerdctl ps. This is the one I started first, this one here, and this one is our second one. So the container ID is actually just nginx1 because it's what we passed. So here we have one that we started with nerdctl and one that we started with our Golang code. So they're both running. nerdctl exit IT nginx2 binmush. You see, this is the first one. I mean, this is the Golang one. This is the one that I run with nerdctl. So they both work, but the difference is that the one that we run with our Go code doesn't have networking. So I do curl localhost 8080. I actually get on this one. And this is because nerdctl actually does a lot of things for you from the command line besides using containerd. And I can show you all the things it actually does. So if you have a look at containerd, so you see here, this is the containerd rootless that is running containerd. And there is, this is running under the user. And it has actually its own networking namespace. So if I look here, IPA, I get two interfaces, but there's another interface that we don't see. So we need to do namespace enter, and then you need to give the process ID. I think it's this one. And now we are actually in this namespace of this containerd, where this containerd is running, and then we have access to all the other interfaces, tab 0, nerdctl 0. And these are the networks that are configured by nerdctl by using hooks in its code. It will reach out to containerd to start a container, but then it will still do a lot of extra commands, some nerdctl internal commands to create these networks within this namespace of this user. So that's pretty nice that it does. It's just very difficult that there is no API for us to easily do the same. There's an API to expose port 8080. So if you have a look at port 8080, it is actually bound by this rootless kit, and there is an API somewhere. There's an API sock, and here we see if we connect using curl to this socket, then we can see that there is a port defined. So this port will be exposed because nerdctl actually made a connection, or containerd actually made a connection because there's a hook to this socket to create this port so that you can listen to it. And then when you connect to localhost 8080, it will redirect you to this rootless kit because that's where it is listening to that process, and then it will map it. So if you have a look here, So there's also some mappings here in IP tables to forward it. This is not very interesting. We need to get a NAT table. The NAT table. So here we will see that port 8080 is actually, we set a mark here to the port forwarding DNAT destination port 8080 to 104010. So you need forwarding using IP tables. You need to make sure that you listen on port 8080 on the VM, and then you also need to make sure that you have 104010, that you have this interface here, a bridge interface. So there's a lot of things to do still, that if you would use the Docker SDK, then here, if you would use the Docker SDK, you pull the image, you create the container, you start a container, and the container waits. So you see the APIs are very similar. But here, if you're then going to have a look at create container, we see that we actually have a networking config. Specify an IP address, how it links. I have the port bindings, the host config. So there is definitely a much richer API available if you would use the SDK from Docker itself. So I hope that in the future they will actually make it easier if you just want to use the containerd tooling, the open container from the Open Container project. So from the Open Container Initiative, if you would want to just use that tooling, would be interesting if there was an easier API available. And there might be, maybe I just missed it in the tooling I was looking at. So definitely leave me a comment if there is now something available or you know something that is available. So here we are still then waiting until our container exits so we can stop the container, stop both containers, remove them both, and we will see that our task exited with state 0, which means that it successfully ran and shut down. So I'll make sure that this code is available on my GitHub so you can have a look at it. And if there's an easier way to do the networking, then just hitting all these commands, these IP table commands, because that is what actually nerdctl is doing. It then is doing all these IP table commands. I have somewhere here a log where I was checking with strace. I'll look for IP tables. Then you see here that it just uses the exec command. This is from containerd. It just uses the exec command at some point to exec user bin IP tables. So it's not really using an API of some sort. It's just executing these commands. I think that's the same way that Kubernetes is doing it. And then we can also have a look at the configuration of nerdctl, what it is actually passing to containerd. We first need to know the containerd process ID 1503. So if you have a look at proc 1503, the root file system, and then run containerd, runtime v2 task, default. Here we have a config.json. And here we can see what it all passed to containerd. So if I less this, then here we see the hook. So it passes to containerd a hook. To create a runtime, it needs to execute nerdctl with internal OCI hook, create runtime, and with this environment. So this is how it actually makes sure that it is setting up the runtime. So there's definitely some extra setup that is necessary that nerdctl is doing to get this networking setup, just besides plain containerd. So if you wanted to set up networking yourself, then you would have to have a look at the rootless kit, how to set up networking here, maybe with nerdctl, making sure that you first do the ns enter so that you are in the correct namespace. But also this is just a tool, a VM, a Linux VM, to run Docker containers on your local machine. So you don't really need the rootless kit and the containerd and the namespaces to shield everything. If you just run an instance on a cloud provider, you could just run containerd. You could just run everything as root and make sure that you execute some commands to set up the networking once you start a container. So that's also an option. So I hope this was useful. Let me know what you think in the comments.